Good evening and welcome to our video tutorial. I think this is the first video for your class and it's long overdue. Sorry it's coming a little late. It's a kind of a summary on the orthographic projection. By now I believe you already know what orthographic projection is. A system of projection in which views of objects are projected on various reference plane. Okay, and you have the different reference plane, that is the horizontal plane, the vertical plane, and the side or profile plane. And these views that we talked about are the front view, the top view, the side view. These are the basic one we work with. Okay, they are the basic one we work with. Okay, then we have another definition here that says orthographic projection are a collection of 2D drawings that work together to give an accurate overall presentation of an object. Now, this is 3-dimensional. This is 2-dimensional. You can simply say orthographic is converting a 3-dimensional object to 2-dimensional. You'll be right. Okay, orthographic is also called working drawing or production drawing. Okay, look at here, a collection of 2D drawing that work together to give an accurate overall presentation of an object. These 2D view work together to produce the given object, and that is why it is called working drawing or production drawing. Okay, you can call it either working drawing or production drawing. Okay, now the principal view of projection, we talked about this before. Okay, we talked about this before, where you have your top view, okay, which is also called the plan, where you have your top view, right? You have the bottom, the front, the back, the left side, and the right side. Take note, this left and right side view are what is called as profile view or elevations. Okay, so these are the 6 principal view of projection. Every object can be projected this way, but there are some objects that have maybe one view. Whichever direction you are looking at them, you see them, they are just 1 or 2 view. Okay, 1 or 2 view, but basically these are the 6 principal view of projection. And like we did mention in auxiliary view. Okay, any other projection, okay, any other view, other than this 6 principal view of projection is what we call auxiliary view. I hope you remember that. Okay, now you have the plan here at the top, the front elevation, okay, underneath the plan, and you have the bottom underneath the front elevation. Then you have the right side to the right, the left side to the left, and you have the rear elevation here. This arrangement here is third angle. Okay, in orthographic we don't need all of the 6 view. All we need is the top, the front, and the side. These 3, because these other 3 look similar to these 3. Okay, if you see this front view and the rear view, the difference is this part here that is visible and the back here is not visible. Okay, if you look at the top, okay, this line that is visible here at this point is not visible. Okay, if you look at the side, I think the side looks similar. Okay, so 1 will be okay. So we don't need to produce all the 6 view. We need just the front, the top, and 1 side view. Okay, except when it is necessary to produce all the 6 view. That is when it is produced. Okay, so basically this is the arrangement. Okay, this is the arrangement. Then you have some basic idea on this already. Okay, now guide. You have an object, you want to produce it in orthographic view. How do I go about it? That's the question. Okay, and that's the aim of this class. Now when you have an object, you look at different factors. One, you look at where should be the best position for front view. Okay, and usually we choose a view that expose details of the object, not a view that hide details. Okay, because the essence of orthographic is for us to produce an object. So if we hide the details in the views, then it will be difficult for us to produce it. So we look at the view that carries more details, that the details are exposed, they are not hidden, and then we pick that view as front elevation and then produce it as front elevation, then the top, the bottom, and all of that. Okay, so like this now. Okay, if you're looking this way, it will give you the top. Looking like this will give you the side. Looking like this will give you the front. Looking like this will give you the side. Okay, now in this particular object, okay, the front and back will look similar, the top and bottom will look similar, and the profile view will also look similar. There are objects that every view look different. Okay, there are objects like that, and such objects should be produced depending on the requirement. Okay, glass box approach. Now this is here to show you how this is done. Okay, the object is put in a glass, and then the various views are projected. This is front view, projected in front of the object. Okay, in a situation where a question is presented, normally you have an arrow that indicates the direction of view, but in the situation where there is no arrow indicating the direction of view, you can look at the object, okay, and assume your front elevation, then indicate. Okay, that is accepted. Okay, then we have the front and the top. Okay, here we have the front, the top, and the side view, and at this point we have we lose the glass box unfold. Okay, the glass box was unfold, and you have the top view at the top, the front view beneath it, and the side view by the side of the front elevation. Okay, with this you should know what arrangement is this. Okay, this is third angle, this is third angle. Okay, so now this is there, the glass experiment there is there for you to help you understand the projection better. Okay, now coming to first and third angle orthographic projection. First and third angle orthographic projection. Now in first angle, okay, in first angle you have the front elevation, the plan underneath it, and you have the right side to the left side of the front elevation, and the left side to the left to the right side of the front elevation. Okay, then in third angle you have the plan and the front elevation under the plan, and then the right side to the right side and the left to the left. Okay, now the reason why first angle is like this is because of this projection. It's because of this. Okay, now if you look at this arrow, okay, the direction of view is this way, but the projection is done to the other side, which is this side. Look at the direction of the arrow here, but it's projected that way. Okay, okay, then look at the direction of the arrow from the plan here, and it's projected downward. But in third angle, the projection is projected towards the observer. Okay, towards the observer, not away from the observer, as in the case of this. Okay, so this is the difference. This is why you have in first angle you have left side to the right and right side to the left. Okay, and that is why you have the front elevation at the top and the top view or the plan underneath it. Okay, so this is the difference. Okay, then we have okay, the arrangement is this. Okay, like I said before, we need just basic, the three basic. Okay, so if we are to produce the other views here, okay, they will also come with the same thing, but the only thing is those parts that we cannot see, we represent them with hidden details. Okay, so for the purpose of this thing, this is the arrangement: first angle, third angle. I think there is a material I sent to you before that contain details of the difference between first angle and third angle. Okay, you can refer to that as well. So this is the assignment. This is the assignment I gave to you. Some of you did very well, and then some of you left out a lot of details, which is not proper. Okay, since it's a production drawing, we need every detail. We need every detail. Okay, so whenever an object is hidden from your view, you represent it with a dotted line, short dashes. Okay, so every detail is represented. Very, very important. Very, very important. And then whenever you have a circle, okay, or a circular object or shape, you always put the center line as seen in this place. Okay, we have the center line always. You can see this is also a hollow part. You put a center line. The same thing everywhere. You have a circular shape or hollow part, you put a center line. You know the type of line that is used as center line. Okay, so you do that. Now you see that this is not appropriate, this is not appropriate. Sorry, yeah, this is inappropriate, this is inappropriate. Okay, the reason is this view, there are a lot of hidden elements that we can see, but if you look at this view, you can see some of the hidden elements. Okay, so if I can have this and see some element, and have this and see and will not see some element, I would prefer to go with this. That's the reason why this is inappropriate. The same thing with this. Okay, if not, the difference is in this line. This line here is not visible, but by the top is visible. So you go with the view that expose the element very well. So this is the correct thing to do. Okay, I'm sure some of you have done that correction already. Okay, Then we have objects that require only two view. Okay, looking at this object now, whichever direction you're looking at it from, okay, it will give you, aside the top or the bottom that will look like this, every other side you're looking at it from again will look like this. Okay, so if you look at the plan, the front elevation will look like this, the side view will look like this. So they are called objects that require only two views. Okay, so now for those of you that may be going for mechanical, another aspect of engineering, you meet a lot of this later on. Okay, then we have object that have just one face, just one. Okay, just this. Okay, this is basically the thickness of this part, just the thickness, and then represent the center line. So we have objects that are like this. So this is all about orthographic. The aim is that when you see any object, you should be able to, any object given in three-dimensional, whether isometric, oblique, or perspective, you should be able to produce it in two-dimensional, given the various view, and the arrangement is either in first angle or third angle. So if you're given any object in three-dimensional, what should come to your mind is, what would the top look like? Okay, what would the front elevation look like? What would the side view look like? Okay, all of these we'll be making use of them in the next topic, which is on building design. Okay, by the time you design a building, you produce the plan, you produce the front elevation, you produce the side view, the back view, and so many other things. Okay, so please, the knowledge of this is going to be very helpful in our subsequent topic, precisely building drawing. So please study your materials very well. Okay, I gave an assignment on Google Classroom. You have to turn in those assignments by Friday, 11 a.m. Friday. Okay, please do. Since some of you complain of not having your instrument, your board and your instrument at home, I have decided to make all assignment at the moment a sketch. So you can just sketch it neatly, indicating all the details, and then send it in for assessment. Then for those of you that have not gotten your card, that is AutoCAD, please, if you can get it before the next class, it will be helpful so that we can practice together. Okay, if there is any question, please feel free to reach us on any of our social media platforms, and we'll be glad to help out. Thank you very much. Stay blessed. See you again in the next video. Bye.